my link in the existing Hangout?
I saw it pop up, yeah.
You saw it like a pop-up video?
Okay, so someone just joined.
Like a notification. I like how they do chat now.
People drop it off.
Okay, cool.
That's all.
All right,
Success.
and I'm going to say,
Hangout on air, okay.
this will be a webinar, new URL. There. All right. Okay. Mike, if you can make sure that you're on mute. Okay. And hi, everyone. Sorry for the glitch. The URL didn't behave, so we have a new one. So welcome. We are going to be hearing from Michael Johnson, who is the developer for the Xfinity Stream for Web product. And he and his team worked really hard at ensuring that all of their fonts are accessible by being scalable. They don't use, not using Command Plus. A lot of us think, okay, we'll just use Command Plus. Understand that when someone is low vision, they're low vision from the moment they open their computer. So they don't Command Plus, their whole operating system is set for a bigger font. That bigger font then is sent to all applications, of which a browser is one, and that will scale the fonts as long as you don't use PX. If you're using PX, you're overriding that. So I am going to just want to give you that real quickly, tell you why, and I'm going to switch this over to Michael so that he can start with his event. Michael, I'm just trying to find you. There we are. There you do. There we are. Okay.
We got a Hangout link, but we're also just broadcasting it there.
Did you what? It was full? Oh my goodness, it was full. I didn't know there was such a thing as full. We just made a new link. If you know of anyone who is not able to get in because it's full, I didn't know that there was a limit. I am recording this live and I'll send out a link. So if you guys want to, and you're in the building and you want to come up, we're kind of grouping together in 19113. That wasn't the plan originally, but that'll also give you an opportunity or your friends an opportunity if it is full. That being said, Michael, does everyone see Michael's screen? I know we do. Mikey, can you check and make sure we see Michael's screen?
Yes.
Okay.
You can also manually click on Michael in the lower.
Yeah, I did. I just wanted to make sure.
Yep.
Okay, so Michael, why don't you introduce yourself?
Okay, you mute.
Got it.
Good afternoon, everybody. This is Michael Johnson. So move your computer too. No, it's not doing it. There we go. Okay, great. Good afternoon, everyone. My name is Michael Johnson. I'm a principal web developer on the Xfinity Stream Web App team. I've been working on the web app for 5 years now. In that time, I've tried to make it as accessible as possible. You know, just to be sure, we're talking about tv.xfinity.com here, which is the web app for the X1 platform called Xfinity Stream. So on the web app, we have a lot of accessibility features. I've listed them out here. You know, so we tackled a lot of areas of accessibility for various people with disabilities. One area we have not really done a lot in is support for low vision. So our UI is zoomable, as Adina alluded to. That means you can use your browser shortcuts, Command plus on the Mac, for instance, or menu options to zoom the UI size. And this proportionally scales all the UI elements in your web app, including padding and borders and other box model properties. It's nice because it changes the size of the viewport, so it triggers screen size media queries. So you get those nice, juicy, responsive layouts as well, so that everything stays usable at the new size. But again, as Adina said, this is a per page or per tab setting. It's not a global setting, although Chrome now does remember zoom settings for each website you visit, so that's mitigated to a certain extent. And the big problem here from an accessibility standpoint is something called comorbidity, where people will often have several disabilities in conjunction with each other. For instance, someone with low vision may also have a motor impairment that makes it difficult to use the browser shortcuts to zoom or to use the drop-down menus or other options to zoom. So so we want to support we want to be compliant with the CVAA, the Communications and Video Accessibility Act. We want to be compliant with the Web Content Accessibility Guidelines 2.0 or WCAG. And WCAG is pretty clear on text. We need to make sure text on our web sites and web apps is resizable without assistive technology. So we need to support up to 200% zoom without loss of content or functionality. And this extends to what are deemed essential images. And in our case, essential images are posters and network logos. So those have to be scalable as well. So at this point, you know, I have a few screenshots in here, but Adina said screenshots are boring, so I'm going to switch over and do a little bit of a live demo to show you what we're talking about here. Actually, before I do that, you know, I just want to look at the, you know, just talk a little bit more about this. So browser zoom is great; it works well, but again, it's not a global setting. It's not persistent in some browsers, and it can be difficult to trigger. So a more permanent solution is to make fonts scalable. And what that means is using relative units to scale them or to size them instead of pixels, which is an absolute unit. So in this case, so in this sense, type would respond to browser or OS level font size settings. The default is medium or 16 points, 16 pixels. We want to make it a global setting that affects all websites. And more importantly, making fonts scalable means that it's a solution that works without user action. It's something that's persistent and permanent. A couple of important notes we'll get into as well is that scalable fonts work differently than browser zoom in that they do not affect viewport size and they do not trigger window size media queries. So the behavior between the two of them can be a little bit different. Here is a quick screenshot showing you how to adjust font size settings in Chrome. You can use the drop-down menu to pick from some presets, or you can customize them further, change font typeface, and make them super tiny or super huge. Firefox, same thing. In the content panel of the preferences settings section, you can adjust them here as well. So I encourage you to go into your browser and check that out. So the way we want to achieve scalable fonts is by using relative units. So the most common relative unit you'll see on the web is the EM unit. So an EM unit is roughly equal to the width of the letter M character in the selected typeface. And EM units are not absolute. They scale relative to their parent. And this can lead to some pretty crazy nesting problems if they're not used very carefully. So EM units have traditionally been fairly difficult to implement, especially when you're trying to retrofit a website with resizable type. This can be a pretty frustrating experience. EM units are pretty widely supported though, so all modern browsers plus IE 10 and later. So the reason we don't really want to use EMs is because the math gets a little tricky. Again, M's scale based on their parent container. So in this example, if I'm trying to size this nested span, I'm going to get an unpredictable result for its font size. It's not going to be 0.9 EM, as I have written in my style sheet. So you need to be really careful with this, and this could be really frustrating. So I don't blame anybody from shying away from this in the past. But we have a better way forward, and that is using REM. REM is a root M, and it's a unit that is also resizable like a standard M. But REMs are elements sized with REM units calculate their font size based on the root element of the document instead of their immediate parent. So in this case, we can set font size on the HTML element in our web document, and all of our REM font size calculations scale based off of that instead of against their parents. So this avoids the compound nesting problem that occurs with EM units and makes our math a little bit easier. It's supported in all modern browsers and IE11 and IE11. So if your site needs to support IE10 or IE9 or other earlier versions of Internet Explorer, then you could be out of luck with this solution. Our web app uses Polymer, and IE11 is our lowest supported browser. So this REM-based solution made a lot of sense for us to try to implement. So with that in mind, let's take a look at REM font sizes real quick. 1 REM equals is the default font size of the browser, which in this case is 16 pixels. This is the same as for M's. And you can see some of these values are a little bit, remembering those can be a little bit tricky. So this kind of, this makes me a little sad as someone who doesn't do math well in their heads. So luckily, we have something called the golden number for REM fonts. So if we specify a font size of 62.5% on the document root, this results in math that says 1 REM is equal to 10 pixels. So this makes it much easier to remember in your head what the font size is, how to switch between REM and pixel sizes. And this code here is literally what we did for Xfinity Stream Web. We changed the HTML font size to 62.5%. The body font size is 1.6 rem, which is now equal to 16 pixels, and other elements in the CSS scale as well. So headings are 24 pixels. Now they become 2.4 rem. So this makes the math easy. This made the conversion easy, and a very straightforward kind of process. So yeah, we're a little bit happier about this. So this works for box model properties as well. So we use this in a number of places to specify width, height, sometimes padding, sometimes margin, depending on the UI. We didn't convert absolutely every value, but we converted a lot of them to be scalable. So at this point, maybe I will switch over to my browser and do a live demo of changing the font size and showing how the web app reacts to that. And this should be fun because live demos always go well, always go perfectly. So let's try this. Oh, yay, cool. Okay, so here is my Xfinity Stream Web App, and this is in my local environment, but all of this is in the production environment now as we speak. I just like to use local. So this is the web app, the recording screen at the default size of 16 pixels. So if I go into my Chrome settings here, I can see here medium is my font size. I can customize it further here, and this is typically how I do it. I'll use the slider up here to change the font size, and you can see the fonts react in real time as I drag the slider around. So I can go from a minimum, which I think is 6 pixels, all the way up to a maximum of 72, or yeah, I think it's 72. 72 is going to be a little bit big for my small laptop screen, so I'm going to settle on something like, 28. So now if I go back to my recording screen, the UI has adjusted. All of the text and graphics and controls are now much bigger and much easier to read. So I can interact with these the way I normally do. I can use the controls the way I normally do, and everything still works the same. So there's a couple of other screens I can go to here to show you. Well, let me try this real quick. If I do tiny, I'll show you what tiny looks like. If I zoom all the way out, you can see that's pretty darn tiny and not super useful, but you can do it if you want. And then I'll zoom all the way up to huge. And again, this is going to be really kind of big, but again, everything scales. I can read it. I can click on everything. I can interact with everything. Some things start to overlap, but it's not bad. It's not bad. So in in an ideal circumstance, I'd have a much bigger monitor to go along with this much bigger size. And I know a lot of people with low vision do end up using larger monitors to accommodate, having larger type. But this is not bad. So I'm going to put it back to something that fits a little bit better here. So let's take a look at maybe like 20, 28. I mean, we can do 32. We have to support up to a 200% increase, so we'll do 32. So 32. This is more, this is more in the browser zoom kind of range. So this works. If I go to For You, I'll show you. We also scale. Posters. And again, this is because of the WCAG 1.4.5 requirement that says that essential images have to be scaled as well. This extends to logos. If I click on The Simpsons here and scroll down, you'll see the FX network logo is scaled as well. All the text, all the icons and buttons, everything remains proportional and usable at the larger size here. So this extends across all of the screens of the web app, including live TV, where again I can view all of the text and graphics, the channel numbers and logos, all at a larger font size. And you can see it doesn't really fit on my screen that well, but it does. Let me use my font size to zoom. So I can maybe zoom out a little bit, change it to 28. Right. So there we go. See that a little bit better. And again, ideally, I would have a larger monitor to take advantage of having larger type and graphics. This is scrolling much more smoothly on my screen than it is on the Hangout, so I apologize for that. So this even works in the player. So video playback is a very large portion of the purpose for the web app. So I want to make sure that the player experience is good as well. So if I watch this, you'll notice all my player controls are also very large and in charge, and I can use them. With my larger font size here. So again, I'm tabbing now just to show. I have keyboard control as well as larger font sizes here. Some of the boxes get a little squished or distorted when I am zoomed into this degree, but those are minor bugs that don't really impact the functionality too much here. So you can see the rest of these are behaving pretty well. This extends to like the on-screen menus as well, or the overlay panel. So this is the info panel. You can see all the text and graphics are larger as well, and dialogues as well. So if I go to the player shortcuts panel, again, we have some clipping issues, but again, it's mostly readable and usable. When we get into this larger font size, dialogues get a scroll bar so that users can get the full access to all the content that occurs in these fixed size kind of panels. So that's the player. I'll close at this point. So I want to switch back to my presentation. Let's see. Share. So again, these are just some screenshots illustrating some of the screens we just looked at. So 16 pixels and zooming into 24 pixels, all the text and graphics scale proportionally now. All the width and height of all the fixed size controls, like the filters button and this popular drop-down menu and the view toggle buttons next to it all scale as well. And again, and some of the player screens as well. You can take a look at those, take a look at these in the slides or live on the web app. At your own pace. So what did we actually change in the web app? Well, all font size properties in the web app changed. Everything that was specified in pixels changed to rems. All of the corresponding line height properties changed as well. Again, we converted from pixels to either rems or percent based on what we thought was more appropriate. Sometimes we transitioned to name values like normal if we thought that was more appropriate as well. We also ended up having to change a lot of the width and height properties of a lot of the fixed size controls, like some of the things I showed you, buttons, drop downs, any SVG icons. again, to maintain proportion between all of the different interface elements. And poster images and logo images, all of those images needed to scale, again, based on the WCAG requirements. We want to make sure we were compliant. We initially did a build of the web app using just font changes, where we had large fonts and tiny posters that didn't scale with font size, and it looked really kind of silly and not that usable. So we ended up changing that. So now everything scales. And again, with the box model, we ran into situations like this where, with large type, we had text bleeding out of a box, and we needed to adjust the box model properties to be REM units as well. Some of the challenges we encountered are media queries. REM and EM units, you can use them in media queries, but they're not calculated based on that, changing that HTML, the font size on the HTML element. You can't adjust this via styling. They always go by the user agent's default font size value. So, 1 rem is equal to 16 pixels instead of 10 pixels like we had in our calculation. This was really noticeable on one of our screens where we changed the number of posters we display per row based on how wide your screen is. And we had to, we changed them to use EM media queries, again, because we wanted that to remain, to retain that functionality when you scaled your font size up. So the math here didn't work out quite exactly the 10:1 that we had used for fonts, but still quite usable. We ended up having to change the responsive header, where previously we were relying on screen size media queries, and again, those were calculated differently in this brave new world of REM fonts. So we now update the size and dimensions of the responsive header via JavaScript. Another big challenge is something I showed, which is the listings page. The listings page uses a custom scroll reveal behavior as you scroll. It's similar to Polymer's built-in iron list component. So during scrolling, rows are removed from the bottom of the list or removed from the top of the list and inserted at the bottom of the list with new content. And the row placement and column widths were all dynamically calculated with pixel values initially. So Jeff Avalone, one of our other principal developers, did a lot of work to rewrite the listings page to accommodate relative font sizes. And the result is really nice. You can the entire UI of that page now responds to your font size, so it's much more usable now and works really well. At larger type sizes, it looks more like the experience you'd have on a set-top box on a large screen, so it works really well. So again, this is again just a screenshot. I showed this in the demo earlier, but this is font size 16 pixels. You can see I can see like 10 rows and like 6 columns, and then again, when I zoom in, or not zoom in, when I change my font up to 32 pixels, I see fewer rows, fewer columns, but everything is larger and proportional, and everything behaves the same way. A couple of other issues. Again, if you're going to implement this on another product, things to watch out for. We saw some mismatched caching on some of our CSS files during our launch window. Where our component CSS files were updated, but our non-polymer base.css file did not. And this resulted in some extra large fonts on the production site for about 5 minutes. But invalidating the caches and getting everything in sync cleared that up. But again, that's just something to look out for and be mindful of. The other thing we saw post-release is some customer feedback, and some users were complaining about their web apps suddenly having large fonts. And this is probably because they had their font size set in the browser, not really realizing that they had done so. Very few sites support resizable text at this point, so it's probably something they changed and didn't see any difference, so didn't change it back. So in that regard, who is doing scalable fonts, at least in our competitive space? Not very many people are out there doing this. So Netflix, YouTube, Hulu, Amazon Prime Video, none of those video-heavy sites really do scalable fonts, although they do support browsers very nicely. Google.com, if you search on Google.com, you'll see a kind of hilarious mix of REM fonts and pixel fonts, so give that a try. So the Stream Web App is really kind of at the forefront, in this kind of space. Kind of going along with our commitment across all platforms for accessibility for the X1 product, to kind of lead the way and show what accessible product development means. So that's my presentation. That's what we've done. Here are just a couple of links, a couple of resources, some good articles on implementing REM fonts and how they interact with media queries, and some links to the WCAG requirements for text and image size requirements for browser resizing. So that's it. Thank you.
Does anyone have any questions?
Sure, this is Tom. Hey, MJ.
Hey, how you doing?
Pretty good. I'm wondering if you used different images scaled up. Like, are you delivering a different image at a higher pixel density or higher pixels when the font is scaled up to a certain percentage?
We are not. We're using the same image. Can you still hear me, Tom?
Yes.
You won't be able to.
No. We're still using the same image. We're not making an additional request. There doesn't seem to be an event in the browser that allows us to detect when the font size changes via the user's settings. So if you go onto the tv.xfinity.com website now and change the font size, you'll notice some things don't update right away. So if you kind of resize the browser window, it'll trigger a reflow, or if you navigate to another page and then come back, it'll trigger a reflow. So there seems to be, at least to my understanding, there's not a way we can tap into that. So right now we are just scaling the standard poster size that we have and the standard image size. That being said, I think we are, in a lot of cases, requesting a poster size that is a little bit larger than what is displayed on the screen. You know, and scaling it down. So when we scale it back up, it's maybe not as bad or not as blurry. I'm not quite sure there. But no, we're not making any requests for like high DPI images when something like this is being used.
Okay, just making sure you didn't find a special trick.
No, sorry.
All right,
Any
thank
other
you.
questions? All right, well, sounds like there aren't any other questions. I have recorded this live. It's going to be on YouTube. Give me about an hour or so to do that, and then I will send out a link. I will post this link both to everyone who had RSVP'd as well as on Slack, and we'll also make sure that the slides are there as well, so you guys can have the links, etc. Thank you, everyone, for coming, and we'll talk to you soon. Bye-bye.
Thanks, Michael.
You're quite welcome. Thank you.
Thank you.
Thanks. Take care, everybody.
Thank you.